Hi. In this section, which is section 4 of chapter 4, we will discuss what we call the indeterminate forms and L'Hopital's rule. Now, this name is read L'Hopital. Okay, so L'Hopital's rule. So, what is L'Hopital's rule? Well, it's about taking limits. We have two cases. The first one is indeterminate form of type 0 over 0. So what does it mean? It means that, so let's assume that the limit of the function f of x as x approaches a equals 0, the limit of g of x as x approaches a equals 0. Now you're taking the limit as x approaches a of f of x divided by g of x, which means when you apply the limit to the numerator and denominator, you're going to get a 0 over 0. 0 over 0 in calculus is an indeterminate. It's not determined. So if you have a case of 0 of 0, such as what I explained here, L'Hopital's rule says that to continue taking the limit, you can take the derivative of the function f of x divided by the derivative of the function g of x, and then apply the limit as x approaches a to the quotient of the two derivatives. So this is what we call L'Hopital's rule. This is not a quotient rule of derivative. It's just taking the derivative of f of x divided by the derivative of g of x, and then apply the limit as x approaches a to that quotient. For example, we know if you take the limit as x approaches 1 of x squared minus 1 divided by x minus 1, first, when you evaluate this expression at x equals 1, you're going to have a 0 over 0. Now, instead of using L'Hopital, let's just do the way we learn in chapter 2. So in this case, we learned that you can factor out the numerator. You can factor the numerator as a product of two factors, like quantity x plus 1 times quantity x minus 1 divided by x minus 1. So here you can simplify x minus 1, and then you end up with x plus 1. When you take the limit as x approaches 1 of x plus 1, it gives you 1 plus 1, which is 2. So this is a regular way we learn in chapter 2. But let's apply L'Hopital now in this case. So again, to apply L'Hopital, when we have this limit, we plug in 1 for x, we get 0 over 0. So that gives us the green light to use L'Hopital because we have a 0 over 0. So L'Hopital says to take the derivative of the numerator, which means we're going to take the derivative of x squared minus 1, which will give us 2x. And then when you take the derivative of the denominator, give us 1. So we end up with the limit of 2x as x approaches 1, which is basically 2 times 1, which is 2. So here's another example. We have the limit as x approaches 0 of sine of 4x divided by tangent of 5x. So when x approaches 0, we know on the numerator we're going to have a 0 times a sine of 4 times 0. On the denominator we have tangent of 5 times 0. Sine of 0 is 0, tangent of 0 is 0. So we get 0 over 0, which is HR stands for L'Hopital's rule. So we have the green light to use L'Hopital's rule. So L'Hopital's rule says to take the derivative of the numerator divided by the derivative of the denominator, and then take the limits of that quotient of derivative. So by the chain rule, when you take the derivative of 4x, the derivative of sine 4x, you get 4 times cosine 4x. Chain rule again, when you take the derivative of tangent 5x, it gives you 5 times secant square of 5x. So again, you plug in now. Then when you take the limit as x approaches 0 of this quotient, you will evaluate x at 0. Evaluate x, the two functions at 0 for x. So you get cosine of 0 is 1, and then times 4, give us 4, and then secant of 0 is 1, and then 1 squared is 1, times 5 will give us 5. So we end up with the answer 4/5. Now we have we discussed case 1. There's a case 2 of the indeterminate form of type infinity over infinity. So L'Hopital's rule case 2, which is indeterminate form of type infinity over infinity. We call that case 2. So if you have this case, you can still apply L'Hopital. For example, when you take the limit as x approaches infinity of the function f of x, you get either plus infinity or minus infinity. You take the limit as x approaches a of g of x, you get plus or minus infinity. So when you take the limit as x approaches a of the quotient of f of x divided by g of x, you're going to get plus or minus infinity. Okay, so you get this possible version. So that means we can apply L'Hopital, okay, because we have the green light to use L'Hopital. So L'Hopital says to take the derivative, to take the limit as x approaches a of f prime of x divided by g prime of x. So let's take an example. So here we have the limit as x approaches infinity of e to the 2x divided by x minus 1. So when you let x go to infinity, e to the 2x will go to infinity. And then x minus 1 will go to infinity. So you have a case of infinity over infinity, which means we can apply L'Hopital. So L'Hopital says to take the derivative of the numerator divided by the derivative of the denominator. Now when you take the derivative of e to the 2x, by the chain rule, you get a 2 times e to the 2x. And then you take the derivative of the denominator, it gives you 1. So you get the limit as x approaches infinity of 2 times e to the 2x. We know as x goes to infinity, e to the 2x goes to infinity. So infinity times 2 is infinity. So it's a case where the answer is infinity. You have another example. Let's look for another example. So let's take this example. I have an example in mind. This one. So this example. So you have the limit as x approaches infinity of natural log of x raised to the second power divided by x squared. So basically it's something like that. But when you let x go to infinity, so natural log of infinity will go to infinity. Infinity squared is infinity. And then x to infinity, x raised to infinity squared gives you infinity. So you end up with infinity over infinity for this problem. So we can apply L'Hopital's rule. Okay, L'Hopital says to take the derivative of the numerator divided by the derivative of the denominator. Now, the derivative, we use the power rule followed by the chain rule. So you drop 2 times ln of x and then times the derivative of ln of x. At the bottom, x squared, its derivative is 2x. And on the numerator, the derivative of ln of x is 1 over x. So on the numerator, you end up with 2 times ln of x times 1 over x. On the denominator, you have a 2x. So then you can, so this 1 over x, so x goes on the bottom. So you can write 2 ln of x over 2x times 1 over x, something like that. So you simplify 2, and then you multiply x by x. So you get ln of x over x squared. So when you let x go to infinity, you end up with infinity over infinity again. So this is the second time you're going to apply L'Hopital's rule. You can apply as long as you see infinity over infinity or 0 over 0, you can continue to apply L'Hopital's rule. So L'Hopital's rule says to take the derivative of the numerator divided by the derivative of the denominator. So when you take the derivative of the numerator, ln of x, it gives you 1 over x. And then when you take the derivative of the denominator, which is 2x, x squared, it gives you 2x. So you have 1 over x divided by 2x. Okay, so 1 over x divided by 2x, which basically means 1 over x times 1 over 2x. So here you have two fractions, you multiply, so you get 1 over 2 times x squared. When x goes to infinity, x squared goes to infinity. Times 2, it goes to infinity. You have 1 divided by infinity, which is 0. So I the same problem, I use a different way, different version to do it. So this is the original problem. So we can write this problem as, because of the square on top and the bottom, you can write this as ln of x over x times ln of x over x. Then you're taking the limit of a product. By definition, is product of limits. So you're going to apply the limit as x approaches infinity to ln of x over x times limit as x approaches infinity to ln of x divided by ln of x. Okay. So so then you do one of them, because you have two the same limit. So what is the limit as x approaches infinity of ln of x divided by x? When x goes to infinity, ln of x goes to infinity, and x goes to infinity. You have an infinity over infinity, which means you can apply, you have the green light to use HR, L'Hopital's rule. Okay, so you take the derivative of ln of x, it gives you 1 of x. You take the derivative of x, it gives you 1. So you end up with taking the limit as x approaches infinity of 1 over x, which means 1 over infinity, which is 0. So you get as 0 times 0, it gives you 0. So the answer is 0, as we did before. Okay, thank you very much.